All right, we clicked a button. Let's wait and see if it shows up on YouTube. I'm not sure if it's here yet. It says it's live. We have viewers now. I think it might show up. It looks like I'm live. Okay, cool. The best part of, I want to say waking up is Folgers in your cup, but no, that's not this. Hey everybody, how's it going? I am Richard Gottlieb, one of the developer advocates, or I guess developer relations engineer now. We changed our titles at Chainlink Labs. And yeah, it looks like you all know the drill because I see hello from Portugal, Indonesia, Ghana, Germany, all sorts of people putting where they're from. That's what I like to ask when we start these things is where the heck is everybody from? Just to get a sense of how global this is. And it's always amazing to me how ridiculously global it is. Somebody dropped a howdy in the chat. What's up, howdy? I'm in Texas. I like seeing howdies. How is everybody doing this morning? Or time of day, I guess, where you're from. We've got India, Korea, Toronto, Argentina. Man, all over the place. Hopefully y'all are looking forward to learning some CCIP over the next 3 days. I myself will be teaching today. Tomorrow we have Andre, and then on Wednesday we have Darby as well, but we'll get into that in just a minute. And yeah, if you haven't already, we've got a Git book out here that will give you all the instructions that you need. I'll go ahead and post that here in the chat with a link. That Git book will give you everything that you need to follow along and go through this bootcamp. Kind of the flow of things is I'm going to go through the examples myself. I think it'd probably be good if you just kind of watch, follow along, not necessarily with me at that point. Then you'll have time to go and do the exercises yourself. That's built into this bootcamp. So you will have time to do the exercises while I'm doing them. If you want to just watch, maybe follow along a little bit to get a sense for how things are going, I think that'd probably be best. To start things off, we have some setup instructions. Hopefully you got an email. You got these instructions ahead of time, but you'll need things like MetaMask. You'll need a GitHub profile. You'll need testnets added to your MetaMask. You'll need some tokens, Link, AVAX, ETH, ARB, USDC. And we have a link to Discord if you have any questions. I see that there's a question here. Will this video be recorded? Yes, so it'll be on YouTube. I think that's where you're watching it right now. You can pause, you can rewind me. You can pause, you can rewind me, just like that, but in real life. And as soon as this finishes, the stream finishes, you can then go ahead and rewatch it as well. It'll be on YouTube. So yeah, I think we're ready to go. If, while I'm kind of talking through the logistics of the bootcamp, you haven't done these setup instructions, I would recommend doing them. Probably be good if I shared my screen though, when I'm talking about things and pointing to them on my screen and you can't see them. So we have our Git book here. This is going to be all the instructions that you need. Again, we have things that you need, these setup instructions. If you haven't done them, now's the time to do them. Go ahead and get everything set up and we'll be good to go. So let's talk about this CCIP bootcamp. What's up? Welcome to the bootcamp. I'll be going through this Git book with y'all. It's kind of how the flow of things will go for the bootcamp. So you can follow along, and the curriculum for this. If you complete everything and you do your homework, yes, unfortunately, there is homework. Maybe fortunately, because that's where you're going to learn the most is in that homework. If you complete all the homework, you will get a certificate of completion. So that'll be awesome. We have the curriculum here. So day one, we're going to talk about CCIP. We're going to talk about transporter. We're going to introduce like what CCIP is, what it solves, some real world use cases, how to use it. We'll go through an exercise where we'll deploy a contract, actually send tokens cross chain, and then you will have your homework. And at the end of today's session, we'll have a talk with the Interport team. So they're actually a DeFi app that, or the app that will use CCIP. They're using it in the real world, kind of as a great way to see how you can actually apply this stuff in an actual application. Day 2, kind of the similar setup, right? We start with theory. We talk about the architecture of CCIP and the messaging process and building cross-chain NFTs. And then you'll have 2 exercises on day 2. The first is going to be building that cross-chain NFT, and then we'll have another exercise for testing it. And again, you'll have homework and a talk with the team from Cello. And on day 3, we'll have the 5 levels of cross-chain security. We'll have another exercise for sending USDC cross-chain. And again, you're going to have some homework, and we'll be talking with the BNB chain on day 3. So if you complete all of your homework, that's how you'll get that token of completion. So yeah, I'll try to keep up with chat. Man, y'all are busy, busy, busy. If you have any questions, feel free to drop them in the chat right here. I will do my best to answer them. We've got a couple other people from the Chainlink team in here. They'll probably be answering questions in the chat as well a little bit. If you don't get your question answered, feel free to spam it slowly, a nice slow spam until it gets answered if it's an important question. And I'll do my best to keep up. Somebody's asking a very important question here. Is there a deadline for the homework? Yes, the deadline for the homework is August 25th. So August 25th is a deadline for the homework. So get it in before then. All right. Before we get going too much, just wanted to talk about something coming up in October. We have SmartCon. So SmartCon this year is going to be in October, at the end of October. It's going to be in Hong Kong, and it's basically Chainlink's amazing conference where all the different leaders in the industry basically come together and give talks, do some networking. You can see awesome projects there, and it's a great time. Last year it was in Barcelona. It was amazing there, and I think this year it will be awesome as well. You can register right here. It's links in the Gitbook, or if you want to scan this QR code, although I think it's always hilarious when we use QR codes because we always say, never scan QR codes, but hey, you can trust this one. We also, before SmartCon, have the Hacker House. So this will be a place for building alongside other developers in this space. So before SmartCon, we'll have a separate event, the Hacker House. It's going to be awesome. You can sign up for that as well. And then one other thing, not to sell this bootcamp short, but when you get done with this one, you're like, man, I need more bootcamp in my life. We have another bootcamp coming up at the end of September for tokenized real-world assets. And you can sign up for that here. So hopefully you enjoyed this bootcamp and you want more bootcamp in your life. This is where you can sign up for that. I think that will be another amazing bootcamp. All right. We'll look through the chat real quick, see if there's any other questions. Somebody mentioned they tried a faucet earlier today, but it seems broken. I'm not sure which faucet. I know that the USDC, the Circle faucet, does sometimes run out of stuff, this faucet.circle.com. So if you just try it again in an hour or so, it'll probably be working then. And yeah, let's talk about who the instructors are. So we've got Richard Gottlieb. Who's this guy? That's me. I'll be doing the bootcamp today. This is my Twitter, my email, I guess, if you want to do that. Andre will be your instructor tomorrow. Andre is a powerhouse in the space, probably way more knowledgeable about CCIP than me. So if you have any super hard questions, save them for tomorrow. But no, feel free to ask them today too. And there's his information. And then finally on Wednesday, we'll have Darby. He's one of our developer experts from the community who will be leading the bootcamp on Wednesday. Will the tokenized bootcamp be live streamed? I think probably it will. It's a good question. Probably be the same setup as this where it's on YouTube is my assumption, but yeah. Do we get access to the Gitbook? You should, in the chat, see a link to it. Let me go ahead and just drop it in there again. You should have access to it. There you go. All right, we're gonna start things off pretty easily here. If you in the chat can just give me a +1 if you've heard about Transporter. And no, not the amazing Jason Statham movie, but Transporter from Chainlink. Just in the YouTube chat, just drop a +1 or a thumbs up, one of the two. Got a couple +1s, cool. Okay, so a few people have heard about this. So this is probably just like a little warm-up exercise, just to kind of, get everybody comfortable with like moving things cross-chain. Transporter is essentially a bridge for bridging tokens from one blockchain to another. It's built on top of CCIP, and it enables you to send those tokens like ridiculously easily between chains. If you want to watch a video at a later point, Alif, who's also on our team, she created a video on how to transfer between different chains using Transporter. We're going to use the testnet version of Transporter. So if you head to test.transporter.io, you should see something that looks like this. Pretty cool interface, right? We can select what network we want to send from, which one we want to send to. And remember, we're at test.transporter.io. You want to make sure, I'm just pointing it out here, a couple things. Test.transporter.io, make sure it says testnet here. I don't want anybody accidentally sending stuff on a mainnet when they don't mean to. If you take off the test, you will be on actual Transporter's mainnet deployment. And so you will be sending, real money, not fun money, between chains. So the first thing we're going to do with Transporter is we're going to go ahead and connect our wallet. Once we get that connected, you should see your address up here, and you can select a network. So for this one, we're going to start on Avalanche Fuji, and we're going to send it to Ethereum Sepolia. And I'm just going to send some, I don't know, we can pick USDC. You could pick BNM as well if you want. This is one of our testnet tokens. It's a burn and mint token, but I'm going to pick USDC for now. I'll go ahead and just send 2 across, and we can pick if we want to pay for fees in Link or AVAX. Link is normally a little bit less expensive, so we'll use some of that Link that we have in our wallet. If I take a look here at my wallet, we can see, I've got my AVAX, I've got my Link, I've got my USDC. All right, so we go ahead and do this. We say we want to approve, and then we get this interesting option. So what we're doing here is we're giving this dApp the ability to use the USDC on our behalf. We can do a one-time approval or an unlimited approval. If we do one time, we're going to set a limit for how much it can send. If we do unlimited, we're basically saying Transporter can always pull USDC out of our wallet. I'm going to pick one time. It's going to ask me how much I want it to be allowed to spend. So I'm sending 2. I'll set my cap at 2. I'll click next and approve this. So this approval is approving that ability for Transporter to send that USDC. And again, you're going to have time to kind of follow along here in just a minute and do this on your own, following the instructions in the Git book. So waiting for this approval to go through. And then we'll approve spending that Link token as well. So we need to approve both the USDC and the Link token. And now we can actually send it. So we'll click send. And we'll go ahead and confirm this transaction. And then we can see that it's in progress, right? So what is going on here? We are actually waiting for the transaction to take place on Avalanche. Then we're going to wait for it to go through CCIP, and we'll take a look at what that looks like here in just a minute. And then we're going to wait for it to show up on Sepolia. So we can view our transaction on Snowtrace right now if we wanted to and see this transaction. Uh-oh, looks like it failed. Something went wrong. I think maybe it was the gas fees. We'll go back and we'll try again. Whoops. So send from Fuji to Sepolia. Let's try B&M. Send 1. We'll send 0.1, 0.01. Sure. We'll approve it. Yeah, somebody's saying the gas expense right now, and I think that may be part of the problem. Okay, there we go. So our transaction was confirmed on Fuji. We can see it's being published to CCIP. If we click on View Transaction, it will take us to the CCIP Explorer. So this is where we can see the actual CCIP information, right? So we've got our source finalized. That means on Fuji, that network has finalized the information there. And so now it's being sent through CCIP to Sepolia. So if you wanted to follow along, all the instructions are here. We are going to take probably like 5-6 minutes, maybe 10 minutes. We'll take 10 minutes here. So you all can go ahead and do this. This is just a good little warm up to make sure, 1, you've got your tokens set up, 2, your wallet is ready to go, and everything is good there. So while we wait for this transaction to complete, if you want to follow those steps, that would be awesome. That'll make sure you're ready to go for the next exercise that we'll be doing in a bit, and it'll make sure you're set up for success for the next couple of days. So with that, I'm going to pop myself off stage. And if you all have any questions, feel free to drop them in the chat. I'll be watching that, and we'll give it, say, 10 minutes. We'll pick back up on the half hour, and I'll see you then. I guess I'll pop back on real quick and start answering some questions because it looks like you all have a few questions. So we have a question about what blessed means. That is a great question. If you go take a look at our documentation, you can learn more about that, but just at a high level. So we have this thing called the risk management network, and that will actually take a look at the Merkle root for the transaction. And if everything looks good, then that gets blessed and added to it's part of the commit store. So that's part of what goes into that. So if you head to the documentation at docs.chain.link, now you can find out more information there. That's a good question. Somebody's saying they're having trouble connecting their wallet. It should be, so if you are here on Transporter, and let me go and find this in thing, and we have here the Connect wallet. It should be pretty straightforward. We should be able to accept the terms, pick your wallet. In this case, I'm using MetaMask, and pick which account you want, click next and confirm. That should get you going. There were some questions about how long it takes and if it depends on the chain and stuff. And yes, so it absolutely does. If we look at, well, when our transaction was going through, we noticed here that it said finalized at one point. And so one of the big things that's going to determine how long it takes is what your source chain is, because we wait for finality. So we wait for the source chain to get to a point where it can't like roll back the transaction. Fuji is one of the faster finality chains. That's why we kind of use it in demos for a lot of these things, because it's quick for that finality. That being said, you know, with the speed of finality and the method of finality, there's always trade-offs. But for demo purposes on a testnet, that's where we're going to use Fuji. And depending on how long that takes, then that can impact how long the actual transaction takes. Somebody's asking, I don't have any tokens to transfer, what to do. If you head back to the Git book here and you go to setup instructions, you can get some testnet USDC here. You can also get some B&M token as well. If you go to docs.chain.link here, if we take a look in here, trying to remember where it is exactly in here. If we go to supported networks, testnets, and we take a look here, nope, it's not in here. Where did it go? As always, when you're looking at things live, there we go. So if we take a look at like on Fuji testnet here, down here at the bottom, we have the CCIP B&M token. So we can add this to our wallet here, and from this contract, we can actually mint it as well. So you can go one of those two ways. Just looking through questions. Somebody's saying that their testnet tokens aren't showing in MetaMask. If you're not seeing your tokens over here in MetaMask, you'll need to import them and fill out the information for the token there. And it looks like we are getting some confirmations here that people are going through the entire thing and getting everything done, which is awesome. So yeah, my transaction completed. We can take a look at the transaction. We can see it's successful. And we can see that we transferred our token across from Fuji to Sepolia. Looks like a few people are starting to get duns which is awesome. We've got just like another minute or two, and then we'll be going on to the next bit of the bootcamp. We have a question about the homework link. It'll be here in the Gitbook, but we'll get to that. Man, somebody wants to do their homework in class. I was that kid in school. I do have a question for everyone. If I play music in the background, can y'all hear that? Sounds like somebody else added it. Okay, cool. It stopped. Okay. Okay. A couple more questions coming in. Can CCIP send any kind of token? Yes and no. We'll talk a little bit more in just a moment about how CCIP works when it comes to transferring tokens. But some tokens are natively supported by CCIP, I would say, and other tokens can be sent, but you have to be able to create a contract that does like the burning, locking, minting, whatever the mechanism is that you're going to be using. Those are great questions. All right, so if you've gone and gotten a successful transaction, right, you're seeing this like transfer complete. If you click view transaction, it should take you to the CCIP Explorer. Can you just drop that in the chat just so I can check it out and see that, you know, hey, we've got some people who are getting success, and yeah. Yeah, thanks for the feedback on the music volume. Is it better now? Hopefully. We dropped it down a little bit. Or should we just scrap the music altogether while I'm talking? Tebow got success. Post your link, Tebow. Let's see the success. Also, somebody's saying here that they have 0.25 AVAX, but it's not enough to send 1 USDC to Ethereum Sepolia. You may want to try using Link instead of paying natively with AVAX. It seems like stuff is really expensive on Fuji right now. All right. Looks like we're getting a lot of successes. If you want to share your transaction in the chat, that'd be awesome. If not, we'll move on. All right, we'll move on to the next bit. So we've gone through Transporter. This is our warm-up exercise, right? We did all of this stuff. Now we're going to talk about the interoperability problem and CCIP. So at this point, you've already used CCIP, which is pretty cool, right? We used it with Transporter. This is like the easiest way probably to use CCIP. It was literally just, click a few buttons and send stuff cross-chain. At the end of the day, I think that shows the power of CCIP. Like we went from one blockchain to another, but why is that so powerful and important? When we think about blockchains, I kind of like to think about each different blockchain as its own little bubble, its own little, universe of stuff. They all have their different benefits and advantages as well as costs when it comes to those advantages. And each blockchain is really powerful in that everything within it is self-contained, but that's also kind of a negative, right? We have all this stuff that's self-contained, and if something's over here in this other blockchain, in this other universe, we can't interact with it. We can't talk to that blockchain, and that's really limiting in the ability to interoperate between blockchains, right? We can't do that until there's something like CCIP or bridge to go between them. So if you take a look at this image, we can see that we're creating a lane between blockchain A and blockchain C. So what this does is this is basically CCIP creating a lane between these two blockchains, which is great, right? And this is basically what we just did with Fuji to Sepolia, right? Fuji was blockchain A, Sepolia was blockchain C, and we sent information from A to C. That's powerful. It allows us to transfer tokens, right? Like that's great. And that's, like a traditional bridge setup here. Like that's what we did. We sent information from one blockchain to another. And normally in the blockchain space, bridges are one of the, I don't know, I would call them scariest pieces of technology because you're transferring funds from one chain to another. Here we have, Patrick, one of the greats, praying to Vitalik that, his money shows up on the other chain. Even like the TradFi world, I don't know if anybody's ever like rolled over a 401k, but you do this thing where like your money disappears and then you just wait and you're like, I sure hope my money shows up. Like I remember I transferred a 401k from one company to another, from like Fidelity to Vanguard, and it's like the money goes away on Fidelity and it's like 3 days and you're just sitting there and you're like, man, I sure hope that money shows back up again, because it'd be really bad news if it didn't. And transferring between chains is, with a traditional bridge, it's kind of like that, right? Like you got to have the money go away because you don't want it to be on both at the same time. And waiting for it to show up, right? And so what's really great about CCIP is that, you have this like entire process where you see the steps happening, and that's really nice. But also you end up with interoperability because not only are you creating a bridge one direction, but now you have the ability to talk the other direction too, right? So you start to have this interconnectivity between chains, and that starts to get really powerful, right? Because now you can send information from A to C, as well as tokens. So you can send data and tokens, but you can also send it back, so if something happens over here, you can inform blockchain A about it. And as you start to set up more and more of these lanes, you start to get something that looks a bit more interesting, right? Where suddenly all of your blockchains become interconnected, and this becomes ridiculously powerful, right? Because you start to be able to use any blockchain with any other blockchain. You know, if you're in A and you want to go to C and now you want to go to D, you can do that and then back to A, right? So this interconnectedness of blockchains is like the ridiculously powerful part because, you know, blockchains, they all have their benefits and their reason for being why you should use them for a certain thing. This enables you to take the benefits of any chain and really kind of mitigate the costs because, you know, if you need the benefits of another chain, hey, you can do that. You can send data and tokens across to another chain. And I think that's really, really powerful. And it's pretty cool to see that, right? To see all the different CCIP lanes enabling this. And I keep saying you can send data and tokens, and that's because CCIP enables you not just to send tokens, right? So that's what we did with Transporter. We sent tokens across, right? We sent the BNM token, or we could send USDC, right? We can send a lot, but you can also send data with those tokens. And we'll talk about that in a little bit, but that kind of unlocks this other superpower of CCIP when you can send those cross-chain messages as well. So just going to take a minute and look through the chat, make sure I didn't miss any questions. All right, looks good. So asking about, so if projects are requiring contracts for minting and burning on every chain that they want to communicate with, does Chainlink have a standard format, sample contract, etc.? Sort of. We'll talk about this a little bit more, Rick, in just a minute as we're talking through this. Okay, so when it comes to what we can send, right? We can send tokens. We talked about that. We can send data, and we can also send tokens and data. Who can we send these tokens and or data to? Well, so it can be an EOA, so an externally owned account. EOA is like a fancy way of saying a wallet, in my opinion. That's why I think of anytime I see EOA, I just think of wallet, or a smart contract. So you can either send and receive both of those things. So a smart contract can send it, an EOA can receive it, vice versa. If you're going to be receiving in a smart contract, you're going to make sure that you implement CCIP receiver.sol, which we'll take a look at here in a little bit as well. And when it comes to what CCIP looks at, probably at the high level, easiest way to think about this is this basic architecture diagram, right? So we have our user here who interacts with a dApp or their wallets, you know, or something. They're sending a message to the router, and the message is going to have the destination chain, right? So this is going to be, when we think about Transporter, this is us interacting with Transporter. Transporter is going to send, you know, the message and the destination chain to the router on Fuji. We go into CCIP, where the message has the data and the tokens. That comes out through CCIP on the router on our destination chain. So in this case, it's going to be Sepolia. And then from there, your message is going to go to your destination. In our case, it was our wallet, our EOA on Sepolia. So at a very high level, you know, you've got something that interacts with the router on your source chain. It goes into the CCIP world, and you'll learn more about this throughout the bootcamp. And then it comes out on the router on the destination chain, and we end up in our end user. Cool. So high level CCIP architecture, very high level. One thing to note is that while you can send data across, data isn't going to really do anything when it comes to an EOA. So only the tokens will arrive in that EOA. And then if you're sending to a smart contract, the message, the actual data as well, will come across into that smart contract. So for now, like I said, we're going to get into this a little bit more. But for now, you can kind of think of CCIP as a black box. We'll start to look into that black box as the bootcamp goes on. And the router is going to be your interface into CCIP, both from sending it in from your destination or your source chain to your destination chain. All right, so a few things, terminology recap, just to make sure, because I don't know that I covered all of these as much as I should have. So interoperability, that's going to be the ability for different blockchains to talk to each other, right? The ability to exchange information between the networks. CCIP, that's a protocol that we're learning about, right? It's Chainlink cross-chain interoperability protocol. A lane, if you remember those two circles, that's going to be the connection between your two blockchains. That's the unique combination of a source blockchain to a destination blockchain. So each one of those paths in that diagram, that's going to be a lane. The chain selector, we didn't talk about this. The chain selector is going to be an identifier for CCIP for the specific chain. We'll see what those look like here in exercise 1. The CCIP message, that's going to be the information that you're sending to the router that's going to go across the blockchains through the lane. Sender is the person sending the information. That can be either a smart contract or the EOA. Your source and destination blockchains, those are going to be, as the name says, you have your source blockchain, where the information is coming from, where the message is coming from, destination, where it's going. And then your receiver is the smart contract or EOA that receives the CCIP message. And again, one thing to remember, if it is a EOA, an externally owned account, then the data, the message piece won't come through, just the tokens that you sent through. All right. So someone was asking here, so transporter is just an interface on top of the router. So yes and no. So yes, it's an interface on top of the router. You can also send a message as well through transporter. What we did was kind of just restricted to tokens only. So yeah, I think you're on the right track there. And yeah, so no place to store the message with an EOA. Yeah, basically you can send it you can send the message along to an EOA, but it can't do anything with it. It doesn't know what to do with it when it gets it. So it just basically gets, dropped, ignored. Great questions. All right. So let's take a look at a couple of use cases for CCIP in the real world and talk about those. So these are actually from some articles on our blog, but I wanted to just kind of go through briefly, high level, this information. Feel free to come back and read all this information from the Gitbook, because I think it gives you a much better understanding of what CCIP is capable of doing. So CCIP, when it comes to the DeFi space, it enables you to do some things that are really cool, because not only can you send the tokens across, right? But you can also send that data, that message along with it. And I think that that's very powerful, because with that information, you can cause things to happen on the destination chain. So you're seeing this information across the lanes, right? And to that, there's a question about lanes being bidirectional. So a lane is not bidirectional. Sorry, I'm gonna go back real quick just to kind of cover this. If we go back here and we take a look. So this right here, this is a lane, right? So you have, it's one direction, but lanes, when we set them up with CCIP, we normally set them up like this, right? So when we add a new blockchain, we set up lanes in both directions. So if you think about it like a highway, the highway is bidirectional, right? But your lane, unless things have gone terribly wrong, are not bidirectional. It reminds me of a joke, I forget what cartoon it was. I want to think it was, there's a cartoon called Bonkers back in the day. Anyway, and he's going down a one-way road and he's going the wrong way. And his buddy's with him and he's like, "You're going the wrong way, it's one way." And he's like, "But I'm only going one way." Anyway, so lanes are one direction, but normally they're set up in a pair. Hopefully that clarifies things. So when it comes to this messaging, right, that enables you to call functions, send other data along when you do this, which is really powerful. And we'll take a look at why that's really powerful in the next two little examples. But we did have a question about the different types of ways that you could send tokens between chains. And somebody was asking specifically about USDC. So there are three main ways that you can send tokens and deal with, like, the source chain and the destination chain. So the first one is burn and mint. So what that means is, like, on your source chain, you're going to burn the tokens, you're going to destroy them. Then when they come out on the other side, you're going to mint new tokens. You're going to create new tokens. And so that's what USDC does, right? It uses burn and mint. So you destroy the tokens on the source chain and you create new tokens on the destination chain. Lock and mint is similar, except for you're not destroying the tokens on the source chain. You're going to lock them up and hold them. And then you're going to create a wrapped version of that token on the destination chain. And then lock and unlock is where you lock them up on one chain and you unlock them on the other chain. So you're going to need like a pool of both on both chains. If we want to see this kind of in a picture form here, we've got this. So burn and mint, right? If we're coming from our source chain, we'll burn the tokens, and on the destination chain, we'll mint them, create new tokens. Same thing going the other way. Lock and mint means that you like lock them up so they can't be used on the source chain, and you mint, create new tokens that are wrapped tokens on the destination chain. If you wanted to go back, then you would burn and unlock those tokens. And then lock and unlock means basically you have a pool that you're locking up some of your tokens on the source chain. On the destination chain, you would unlock some tokens that weren't created right then, right? They already exist, but you're giving them to someone. So hopefully that clears things up, lets you know how things work a little bit. We also have the ability to have programmable token transfers, right? So this is where we can send that message along with it. Somebody's asking, sorry, go back real quick. So to unlock, we always have to mint at the destination. Is it so? So no. So if we have, it depends on which unlock you're talking about, right? If we're talking about lock and mint, so you're going to create that wrapped token on your destination chain. When you get rid of that wrap, like when you're sending that wrapped token back, you would be destroying it. So basically, anytime there's a mint, there should be a burn so that you don't have like a inflationary thing, right? So you have more and more of that token being created. If you're talking about lock and unlock, then you're just going to lock it up and unlock it over here. So you don't always have to have a mint at the destination if you are locking and unlocking. And then the programmable token transfers, basically this allows you to send data along with the tokens so you can do something with them. It's kind of like, if you were to hand somebody a $20 bill with a Post-it note attached to it. But the cool thing about this Post-it note is they have to do what the Post-it note says. They can't just take the $20 bill. So why is that powerful, right? Like being able to send data along. If we look at one of the examples in the TradFi space, there's this thing called delivery versus payment transactions. And basically this is in TradFi a requirement of like when you deliver assets, the payment for those assets has to happen at the same time, like simultaneously. So, it's basically like that. If you want to think about when you're at the store and it's that transaction of like you are getting the thing from the cashier as you are paying them, and that has to happen at exactly the same time. This talks about the Australia New Zealand banking group and what they did with this. But basically, CCIP enabled them to do the delivery versus payments, where you have the delivery and the payments happening simultaneously. And blockchain is really, really awesome for that, right? Because with smart contracts, you can have things where both these things happen at exactly the same time, and they can't happen without each other. In the DeFi space, we also have the ability for cross-chain swapping. I think this is a really cool example that it talks about here with swapping tokens across chains using USDC to kind of facilitate that. So it's kind of like high level how XSwap works, where you have the sender, right? From CCIP, we send to the router, so you're going to send your token and your data, right, to this router. And say you had token A on blockchain A, and you want to swap it for token B on blockchain B, right? Well, token B doesn't exist on blockchain A. How do you do that? And this is where like using USDC is really kind of neat, because you can send into CCIP your token A, and what'll happen is you can swap it for USDC, because USDC exists on both blockchains. So you bridge USDC across the chains, and then you can swap USDC for token B. So this is how you can actually swap assets from two different chains when the same asset doesn't exist on both chains. And I think that's a really cool use case, and it's really powerful, right? And we're using USDC kind of as the token to go between, because it exists on both. So it's the common token in both cases. I think that's really cool. We'll give it just a second, see if there's any questions so far. Doesn't look like there's any questions. All right. I guess we'll move on to the basics of CCIP. How to use CCIP. You already did it, right? We already did it with Transporter. But how do we use it in a smart contract? So we talked about the minimal architecture of CCIP. Just to do a quick refresh. Basically, we've got our transfer tokens, right? So those are the tokens we're sending between. We can send any kind of data. So we can send tokens, or we can send data, or we can send tokens and data. And we can send them from an EOA or a smart contract. And a receiver can also be an EOA or a smart contract, with the caveat that the smart contract has to implement CCIP receiver.sol. We talked about the basic CCIP architecture. And we also noted, don't forget, if you're sending a message to an EOA that has data, the EOA can't do anything with that data. All right, so now we're going to take a look at how to actually create a smart contract with CCIP. We have kind of a choose your own adventure here. Depending on where you're at in your developer journey, we have hard hat. If you want to set up everything for hard hat, we have instructions for that. We have Foundry. If you want to use Foundry, we have instructions for that. And we have Remix. And I'll be using Remix to kind of go through this because it's the easiest, most friendly for just kind of showing, and it's fast to get set up. But if you want to use Foundry or hard hat, feel free to. And I'll go ahead and warn you now, my Remix is in a light theme. It might be shocking, but it'll be okay. I am slowly turning into a light mode developer. I don't know what that says about me. Maybe it's because I'm old. But we have these three options for now. You can also clone the starter kits if you want from our GitHub. And yeah, we've got instructions for how to set all that up. We've got instructions for how to get the contracts. In Remix, if you want to get the contracts, it's just simply importing here. You won't have to worry too much about this because the contract will go ahead and do it for you in just a minute. When we get to exercise 1, we'll see that. Somebody's asking about Brownie. Sorry, we don't have Brownie in this Git book. Sorry. But we've got instructions for how to install for both Hardhat, Foundry, and then Remix as well. Remix should just, when you compile, get the dependencies for you, and everything should be great there, so it'll be pretty easy. When it comes to the basic interface, so what you need just from a basic standpoint to interact with CCIP, like the bare bones, least amount of code possible to interact with CCIP, this is what we need. And I'm really hating Gitbook right now because of this zoomed in view. But we'll look at this code in a little bit more depth in Remix, but we can kind of talk through it now. Oh, Zubin's on the light mode train too. Nice. Nice. Slowly but surely, people will come out and see the light. So let's take a look at, on our source blockchain, we've got two things, right? So we've got our router client interface here. And what this has is it's going to have a function called CCIP-send that has our destination chain selector. Remember, that's an ID for the chain that we want to go to, as well as our message, which is going to be an EVM2, any message. We'll take a look at what that looks like here in just a minute. But so we have our chain selector and our message, and this returns back a message ID, right? So not to be confused, when you say message, in my brain, I want to confuse that with data sometimes, and it's not the same thing. So message is going to be like the entire package of information that we're sending to CCIP. So it's going to have the information about the tokens and all that stuff in it. So the entire thing wrapped together, bundled up with a nice little bow on it, that's going to be your message. It contains your tokens and your data, if there is data, as well as some other stuff. So this message, what's in it? Let's take a look at the struct. So it's got our receiver. That's going to be the address where we're sending things. It's got our data, if we have data. It has our tokens, if we're sending tokens. It has the fee token, so how we're going to pay for this transaction. We saw that a little bit when we looked at Transporter. When we went to send things here, just pick something real quick. We can see here our fee, we can pay with AVAX or Link, right? So it's going to be, are we paying with native? Are we paying with Link tokens? If it's 0, that means that you're going to be using a Link token. And then we have any extra args that we want to send along. So we have our token amounts. Remember, that's going to be another thing. So let's take a look at that. That type, that struct has the token. So this is going to be the address of the token that we're sending and the amount of that token that we're sending, right? So we have our receiver, our data, our token amounts, that's here. Then we have our fee token, how we're paying for it. And we have our extra args. Our extra args contains two things, a gas limit and strict. Yes, message equals payload. That's a good way to think about it. Message is payload, it's not data. I don't know why in my brain, I always confuse the two, but message is not data. Data is part of your message. He's also a great android on Star Trek, The Next Generation. So within there, talking about what we have, so we've got our receiver, right? We've got our data. We've got our token amounts. We've got our fee token. Sorry, I said it the wrong way. Address 0 means you'll pay a native gas. And then we'll put the address of the link if that's what you're doing. So this is the token address. And then extra args. Extra args has two things. One is the gas limit, which is very important. So this is the maximum amount of gas that CCIP can spend when it's calling the function on the destination chain. Unspent gas is not refunded. So it's something to remember. You need to be sure how much gas you're going to spend. There's information here about testing for gas. It's important to make sure when you're actually going to production that you have this correct, that you're using the right amount of gas. And then strict. Strict is this thing that always scares me because you should always set it to false. It exists and you can set it to true. Do not set it to true. Unless you absolutely know why you're setting it to true. But I'm telling you, do not set it to true. Always leave it false. Basically, when strict mode is turned on, that means that you have to execute things in order. And if a message fails, then you can't execute anything else. So you want to make sure that you leave this to false. So strict is always false. Your gas limit, make sure you set it to the right amount, especially when you're going to mainnet. Those are extra args. If you leave gas limit empty, if you don't set it, it's going to set it to a default of 200,000. Cool. So that is the basics on the source blockchain, right? These are the two things that's like the minimum amount of information that you need to interact with CCIP on the source chain. On the destination chain. So that was our sending chain, right? Now we're looking at the destination chain. Looking here at the questions.
Where is the chain selector ID created from? Can a new chain be added? So chain selectors, those would be in our documentation. Here, for example, you can see under our docs, under CCIP, like destination chain selector, you can see your chain selectors in here. So that's where you'd find that information. It's a great question. Any scenario that we should set strict mode to true. I don't know, Andre, if you're around still and you haven't answered that, I would just say for now, no. I'm sure there are some reasons why if you want to make sure that like you never have a failure and like if it fails, it's going to break everything, then you would set it to true. But like I would just always leave it false. Because if you have a transaction fail, then that means nothing else can happen from that contract, right? Like you've set it up so like if it breaks, it breaks. Everything stops. All right, so looking at our destination chain. So we've got our source chain. We've got those two pieces of information that we need on our source chain. On our destination chain, again, we have it looks the same when you first look at it, right? We have the any2 EVM message receiver. This any2 EVM message, this is not the same as the EVM to any. You'll notice they're backwards, right? So EVM to any is from our source chain. So we're going from an EVM to any. And on our destination chain, we're basically saying the opposite of that. We're coming any to EVM. Okay, so the interface that we need on our destination chain is the any2 EVM message receiver. So this is going to be our function CCIP receive. It's going to take in the any to EVM message, right? So this is what we'll be receiving in. So it accepts that any to EVM struct, and we'll see what that looks like here in just a minute. And yeah, please note, it's called out right here. Any to EVM is not the same as EVM to any. Okay, so like, the first time I came across like CCIP, I was learning about it. Like this really caught me up. So I just want to point that out. Like there is a difference here. It's any to EVM versus EVM to any. So on the destination chain, we have any to EVM. Okay, so our any to EVM message, what's in there? We have the message ID. We have the source chain selector. So that's where it came from. We have the sender. So where the data came from. We have the data itself, and then we have the token amounts. Now the token amounts, that is the same, right? So we have our token address and the amount of that token. And it looks like Andre, I think it was Andre chipped in on the chat here, just to point out, somebody's asking about when we would set it to strict. And it looks like, we've updated that. So in the latest version of CCIP, strict is completely removed. And, teaser, more on that tomorrow. Okay, cool. So we've got our any2 EVM message here. We've got our token amounts. And just kind of put it all in one place so you can kind of see it all together. On the source blockchain over here on the left, we have our interface, our iRouter client with our function CCIP send, which has the destination chain, the EVM to any message, and it returns a message ID, what that looks like, the structure of those different pieces of the message. On our destination chain, we have the interface for our any2 EVM message receiver, and then what those structs look like. Cool. All right, so this is like the basics, high levels of what we need to do this. Now we're getting to exercise number 1. Again, this is going to be, I'm going to run through this exercise. It's kind of like the transporter thing where I'll run through it real quick, and then you will have some time to go through this yourself. So before we do that, if anybody needs just a second, I'm going to go through some questions real quick and see Yeah, so we have so EVM to any can send to non-EVM chains. We have our list of supported chains. We'll say we're always adding new chains, and I'll leave that as that. And it seems like there's a lot of questions around that. So yeah. Okay, so this tutorial extends out another tutorial that we have linked here from our docs for programmable token transfer. What's really cool about this exercise is you're going to purposely break things. Because, we want to make sure that we're coding in a defensive manner so that when things break, it doesn't all just fall apart, right? We want to gracefully break so that then we can recover from issues like that when we're creating smart contracts. Again, this is a bit more advanced exercise. I will say, you can follow this exercise if you don't go through any of this and you don't understand what you're doing. It's set up so that you can copy and paste. And be successful with this exercise. You will get the most out of this exercise if you actually understand what you're doing. So we have some information here, some additional learnings if you want to go through that as well. Again, you can do that at your own pace if you need that. But yeah, it's just kind of like hanging out, watching as we go through this. So we've gotten our test tokens. We need to learn how to fund a contract. We'll go through that in just a second. And we didn't go through this previous tutorial, but we'll be okay. Okay, so for this example, we have, we're going to be going from Fuji again. We'll be sending some text along with the CCIP B&M token to a contract on Sepolia using CCIP. We will, need to make sure that we have our gas limit set correctly. And then we have our example contract here, which is ridiculously large to look at in Gitbook. So I'm going to scroll all the way through this, and we're going to open it up in Remix and kind of do the highlights of this contract. Don't be scared if you're like, whew, that looks like about 500 lines of code, because it is about 500 lines of code. But it is extremely well-documented code. So cool. We just opened up Remix. When we were looking at how to set up your environment earlier, it mentioned that, when you import these things, you should see your dependencies folder, filling out all this information, which it did for this. I'm going to go ahead and close my dependencies. In fact, I'm going to close all this over here on the left for now so we can look at this code. Real quick, can somebody let me know, is the size of this code okay? It's about as big as I can make it without having to scroll too much. And I just want to know, when you're looking at it on YouTube, is it readable? Can somebody just give me a yes or a no in the chat? Someone's asking for where we are right now. Cool. There's a link to where we're at right now if you want to follow along. Awesome. Glad it's readable. Hopefully it's not blinding too many of your eyes. You may be wearing sunglasses right now. But Zubin's feeling comfortable in that light mode life. Let's go. All right. So just to go through this at a very, very high level, I'm not going to go through everything because, as you can see, pretty much every line is commented explaining what everything does, which is awesome. If you want to know what something does, it's commented in here, which is great. So we've got our compiler version up here, just kind of going through Solidity stuff, right? We've got our imports. So we're importing in our CCIP interfaces and some stuff for owners and our CCIP libraries, all the good CCIP stuff. We're importing in some Open Zeppelin contracts. If you're not familiar with Open Zeppelin, they're basically the industry standard when it comes to standard contracts like ERC20. So we're importing in some of those as well. Some Open Zeppelin contracts. And we have our, maybe I'm just getting old with light mode. It may be age is catching up with us, Zubin. I don't know. That could be what it is. I just need to mix it up. I don't know. I got tired of dark mode life. So we have our contract here, an amazingly named contract, programmable defensive token transfers. So we've got our ERC20, our map for our bytes to uint. I'm not going to go through everything. We've got a bunch of errors here for stuff like not enough balance, nothing to withdraw, all of the errors here in case we run into those. We have some error code here. So this is basically what our errors will look like. We have our failed message. We've got some events. So when we send a message, we have an event that we emit. When we receive a message, we have one. Message failed, message recovered. We've got some variables that we set up here. Whew, a lot of stuff. And again, if you want to know what something does, it's pretty well documented. I also highly recommend, just as a side note, if you're ever looking at code and you don't know what it does, LLMs do a great job most of the time explaining code, which can be very helpful, right? If you see something and you're like, man, I'm not following what is going on here, pop it into ChatGPT or Claude or something like that, and they will help a lot when it comes to giving you information for what code does. I'm a little dubious on them actually writing the code, but when it comes to explaining it, they've been pretty solid in my experience. I feel like inverting the colors on my screen right now. I know, I understand. I understand that life. So we've got some modifiers here for our code as well. We've got the constructor. This is the little thing that runs when we deploy this, right? And so here we're just setting the link token address in our constructor. We've got a bunch of modifiers. Whew. We've got something to allow list a destination chain. So in this code, we're basically going to set up an allow list for destination source chains. So that means that when it comes to being able to interact with this contract, you have to be on the allow list. So we're going to give each chain that allow list power. We'll see that when we deploy this, interact with it in a minute. Same thing when it comes to senders. We have our function to send our message and pay in link token, right? So here you'll see that this takes in our destination chain selector, our receiver address, our text, the token address, and the amount, right? And we create that EVM to any message. So this is our send function. We're EVM to any. We've got our message set up here with the same stuff, the receiver, the text, the token amount, the address for the link token, because we're paying in link token. We've also then go through, we set up the router, we calculate the fees, we approve using the link token. If you remember, we saw that on transporter as well, where we need to approve that token. You can see where we actually call CCIP send here with our destination chain and that EVM to any message. And then we emit our message sent event and return our message ID. We have basically the same thing, but to pay in native tokens. And again, you'll see here we're using the address 0 for our native token. Set up all basically the same. We've got a function to get the last received message information. We can get failed messages if a message happens to fail. And just a little bit of warning, we're going to have a message fail. And then we've got our CCIP receive, right? So this is where we get that any to EVM message in. So we take that in, and you can see here where we're trying to process that message. We have our function to process that message. This will actually get that. And you'll notice here, we have this simulate a revert for testing purposes. So this is what we're going to actually do. We're going to make this be true so that we revert with an error. So that we can see what happens when we do have an error and how to actually gracefully deal with that. We've got a retry failed message function to try again. And we have our CCIP receive function here. So we're getting that EVM or that any to EVM message, not to be confused with the EVM to any. We have the any to EVM. And we have a function to build our CCIP message. So when we're actually sending that message, this is where we're building that message out. We have a function for withdrawing and withdrawing our token. Cool. So this is like super fast. It's like 545, 550 almost lines of code. But like I said, if you have any questions about this code, pretty much everything is commented, like what's going on with each line. So you should be able to figure that out. But yeah, looks like we don't have a ton of questions. So somebody asked, do you recommend to take this code with fail messages when we write a contract? Yes, I think that you should take most of this code when you're thinking about writing a contract as far as like how to deal gracefully with failures. That's kind of how I'd phrase that. You want to make sure you're gracefully dealing with the failures. This code has that one little piece where you set up a failure to actually happen on purpose. I would probably take that out in actual code. Where's it at? I think it's in process message. Yeah, this bit here, like you wouldn't need this when you're actually deploying that code. This is more just so that we can simulate it, so that we can see like what happens if it actually fails. We can force a failure to happen. So yeah, that little piece you probably leave out. Cool. So let's take a look back at this. So we've done step one. We opened our contract in Remix. Whew, that was a long step one, yo. We've got step two here. We need to compile our contract. Mine's set up to auto compile in Remix. That's why I got this green check mark here. If you don't have a green check mark here, you can turn on auto compile, or you can just click compile yourself. Somebody's asking where you can get the contract example. It's right here in the Git book. I'll paste you that link. Now we need to deploy our contract. And like, I'm going to warn you, this is the, like, my opinion, and maybe it's because I'm a simple man. I don't know. In my opinion, this is the hardest part of CCIP, what we're about to do. We have to switch networks back and forth, and we have to keep track of what network we're on. It gets kind of confusing. So Remix has come out with something new where you can pin a contract. That makes life so much easier. It's like, I used to have two windows open, and it was crazy times. But Remix has the ability to pin a contract. We'll take a look at that now. But we just need to remember we have to keep track of what network we're on. So we're going to start on Avalanche Fuji, right? So like, let's all make sure that we're on Avalanche Fuji. So like, I'm on Avalanche Fuji testnet. Make sure your wallet is on Avalanche Fuji as well. That's where we're starting. Yeah, no, I agree, Zubin, that's it's amazing in Remix to pin now, because this makes CCIP's day. Okay, so in Remix, we're going to go and deploy our first contract on Avalanche Fuji. So cool, let's switch back to Remix here. We'll go down to the deploy and run tab. We've got our green check mark. That means we compiled okay. We'll go to deploy and run. Unfortunately, we're not on vacation in Cancun, but we're going to Fuji. Maybe not so bad. So we'll say inject a provider. Our custom network should be 43.113. And we want to deploy our programmable defensive token transfer contract. You'll notice here that to deploy it, we need a router and a link token address. So what are those? You could get them from the supported networks page and the link token page, or you can just copy them straight from the Git book. So this one ends in 177. So that is going to be our router address. Pop that in here, 177. And then we go grab the link token contract, ends in 846. I always just like to make sure that, I've got the ending correct, because that means I actually copied the right thing. Cool, so we fill out those two things. We'll click transact. Come here, we'll get our confirmation. We'll wait for our transaction to complete. And then we should see our contract right down here in deployed contracts. It's pending, successful. Okay, so our contract is deployed here. We're gonna click this pin contract button. This means that like when I switch between networks, it's going to show up for me. So you want to make sure this is pinned. I'm also going to grab the contract address, and I'm just going to save that over here because I might need it in just a minute. So I'm just going to save that off to the side real quick. Okay, so we've deployed our contract on Fuji. We filled in a couple of things. We proved everything. And now we need to fund our contract with B&M tokens. All right, so we'll go ahead and fund our contract with 0.002 BNM tokens. How do we do that? We come here, we grab the contract address right there. We go up to MetaMask. We say we want to send to an address, and that is our contract. What do we want to send? We want to send BNM, and we want to send 0.002. So we're actually sending this to our deployed contract. We'll confirm this. We'll get that done. Cool, it's confirmed. And then we need to enable our contract to send messages to Sepolia, right? So we need to allow list on the destination chain. The Sepolia chain selector is right here. You can find that on the supported networks page for other chains. So we'll take this chain connector and we'll say allow list destination chain, allow list destination chain. Chain selector goes in here. Is it 753? I think that's it. 753, yes. And we'll say true. We'll go ahead and click transact. So this is going to allow this contract to send to another chain. And then once we've done that, now we're ready to switch over to Sepolia. So again, this is like the hardest part here coming up. So make sure it's pinned when you're going through this yourself. Like make sure it's pinned. We'll go here. We'll switch to Sepolia. See, and this is why it's important to have it pinned because now it's gone. It'll be there when we come back to Fuji, though. It'll be there. So right now, I see there's some questions like about how to do this. If you also want to watch right now, you're going to have time to do this in just a minute. So I'll do a better job of answering questions when you all have time to actually do this on your own. So we switched to Sepolia, and now we need to go ahead and deploy this again. So on Sepolia, we're going to deploy it with the router and link contract address for Sepolia. So A59 on Sepolia. So we'll go back up here, paste this value in here, go ahead and delete this, paste it in, come back up here, get the link token address, 789. I didn't remember to check 789. Transact. So now we're deploying on Sepolia. Confirm that transaction. And we'll need to enable this contract to receive messages from Fuji. So we'll need to allow list the source chain. Waiting for it to deploy. It's deployed. Most important step. Pin that contract. Allow list the source chain. So we'll get the source chain connector 043, 043, true. Copy this address too. Transact. Confirm. Okay, looks like that's good. And now we'll need to enable our contract to receive messages from our contract on Fuji. So we need to do allow list sender with our contract address from Fuji. So when you're going through this, so I have like my little tiny notepad here with my two contract addresses, just so I don't have to switch back and forth. So we'll grab our contract address from Fuji. We'll come up here, allow list sender. We'll paste in that address and we'll say true. This is allowing not just only the source chain, but our source contract, if you will, the sender contract to actually interact with this one that's deployed on Sepolia. So we've got that going. And then we're going to set our sim revert to true. So this is going to be that function. Calling this function is going to set that variable to true that will actually cause our contract to have an error. So if you don't set this to true, everything should work just fine. When you set this to true, it's going to cause an error. It's broken as intended when you call this. So set sim revert here. We'll set this to true. Transact. Confirm. Cool. So at this point, like when you go through this yourself, you'll have deployed your sender contract on Fuji. You've deployed your receiver contract on Sepolia. You've gone ahead and set up everything so that your sender contract can send and your receiver contract can receive. And you've gone ahead and set up your broken bits in your contract when you call set sim revert to make that be true. Okay, so now we're going to transfer tokens and we're going to have a problem and we're going to see how we can actually recover from that problem as well. So we need to go back to Fuji and fund our contract with link tokens. And then we'll actually go through sending that transaction. So we'll go back to Fuji. So remember, make sure that on Sepolia, you've got this pinned. It's up here in my pinned contracts. We're good to go. I'll switch back to Fuji. You'll see when I switch, I'm now on Fuji and I have my other contract here that was pinned. It came back, which is great. So this is now back. We need to take this contract and we need to send some link to it. Given that things are kind of crazy, I'm just going to send maybe 5 link to it just to be sure that we have enough. Since Fuji was having some pretty expensive things earlier, this should be more than enough. Confirm. Pretty sure I grabbed the right address. Let me double check. 46D. Oh. Did I send to the wrong address? I think I maybe did. I didn't get the whole thing. We'll just double check and send it again. Okay, so send some link token to it. And now we can send message, pay link, and we have all of our different information here that we need to fill out this function. So we've got our destination chain selector. So we'll come back into our contract, send message, pay link. So our destination chain selector ends in 753. Is that right? 753. Yes. Our receivers, this is going to be our contract on Sepolia. This is why I saved that in my little tiny handy dandy notepad over here. So we've got our receiver address. We've got some text that we want to say hello world, and then the token that we want to send. So our text, I'm going to say howdy. Our token is going to be that, and then the amount is going to be 0.001, but since we're sending it in its raw form, it's a ridiculously large number, so we'll copy that, paste that in there, click transact, confirm this. At this point, we're going to be sending our transaction across. So we can take a look at the CCIP Explorer here. When our transaction completes here, if we grab our transaction ID, where's it at? I think it's that transaction hash is what I want. Is there the other thing? Did I grab the wrong thing? No. Okay. So here is our transaction, right? So we went from Remix, we went to the CCIP Explorer at ccip.chain.link. We took our transaction hash, pasted it into the Explorer, and we can see the actual transaction happening now. So it's estimating, in about 5 minutes, this will be done. You can see here that we've got our token amount, that 0.001 BNM. We've got some data as well to send across. You can see there's my message, howdy. And so now we're waiting for this to be finalized, blessed, sent through CCIP to Sepolia, right? And once we get to Sepolia, everything's going to break. But it's going to break as intended. It's broken as it's supposed to be. Just remember that. Because we set that to true. Our break function, we set it to true. So if I come here and I switch over from Avalanche to Sepolia, you can see our pinned contract is here. Remember, pin your contracts. Pin them. Pin your contracts. You'll be real sad if you don't pin your contract. If you did happen to copy down your deployed contract address and you forgot to pin it, all is not lost, because instead of deploying, you can come here, put in your contract address with your contract over here and say @address, and that'll load it up. So all's not lost if you didn't pin it, but you'll be good. Okay, so if we come here, it says status success, right? Like nothing broke. Somebody's even saying it like in the chat, like it didn't break. This is, this is often how I feel when like things work the first time and I'm coding. Like, wait, it didn't break? But yeah, no, it didn't break here because so our message sent across successfully. Like CCIP was like, I did my thing. I delivered the message, right? Like it's like the UPS guy, it came to the door, it did everything, like the package is there, but then the package got into the house and like, wow, things were crazy. So what happens, right? So we go here, let's take a look. We've got our source, our CCIP Explorer. We can see here, kind of following along. We see that we've got success, so we're following along. Seems good, seems good. We open the receiver contract. We're gonna look at get failed messages because something broke on our receiver side. So if we come down here, and we say get failed messages, we'll need to fill out the offset of 0 and the limit of 1. So we'll come in here, we'll say offset of 0 and limit of 1, and we'll call, and you'll see, oh, we do have a failed message, right? Like we've got something that broke. Because if we say get last received message, we don't have a received message, like something went wrong. Okay, so let's take a look and see what's going on. So we can see here that get failed messages gives us the value. So we've got our message ID. That's what the first value is. It's going to be different than what's in here, right? So this one ends in AE4. We can see in Remix that ours ends in 9E6, right? So this is our message ID. And then we have the 1, which is going to be telling us that like, hey, this is the error code 1. It failed. So the tokens that we sent across, those are also locked up. Like they're stuck in our contract. So how do we get them out? We've got our retry failed message function here where we're going to pass in the message ID and the token receiver. So that's the address that the tokens are going to be sent to. If I take a look real quick on this, you can see I have 2.015 BNM. So 015, that's the number to remember here. So I didn't get my tokens. Like, how do I get my tokens out of this contract? So we're going to retry the message. We're going to pass in the message ID. We're going to pass in your wallet address there, and then we'll see what happens. So we'll come here, grab my address first. So retry, failed message. So the token receiver, that's going to be me, 5A9. And then here we're going to grab the token, or the message ID, sorry. Paste that in there. Click transact. So you remember my BNMs were at 015. It's pending. This is completed. If we look here, hey, look at that. It updated. It's 016. So I got my 0.001 BNMs. Yes. So we pulled them out successfully from our contract. We could open it up in the Block Explorer 2 and see that information as well. If we look at get failed messages again, we'll see we still have that message ID, but now our status is 0, which means it's been resolved. Okay, so then it goes in exercise and talks about how you could also send the message, pay in link. You can pay in native as well. It walks you through what happens when you receive that message, why it did what it did. We kind of talked through that already. And I think at this point, we'd probably take like 45 minutes or so for y'all to walk through this, make sure you've got everything. One thing to remember is at the end of this, we're going to have a talk with the Interport team as well. So if you finish this and you're just kind of hanging around, you can start on your homework for day one. Let's take a look at the homework really quick too, before we go into this break. Basically, you'll use this form here to answer these questions. So we've covered most of the information in the Gitbook. We also have the documentation at docs.chain.link to help you answer all of these questions. But that is the homework. So if you finish the exercise and you need something else to do while you're waiting for the Interport team, we've got that as well. I will be taking a look at questions as we go through this, answering them as well. We're going to turn that music back on, probably low volume, so I can pop in and answer questions as they come in if we need to, but also be in the chat answering questions. Huge shout out to Zubin, Andre, Tatiana for helping out with answering questions as we've been going through this as well. But yeah, so that's going to be exercise time for you now to go ahead and do this on your own. And I'll be back with y'all in about 45 minutes. As you all get started, somebody saying Remix is not recognizing Avalanche Fuji. I don't know what you mean by that. If you want to drop another message with more information, happy to try to help you out. It may not, like this one says Sepolia, and I know that Fuji, for example, it just says the number. We just have like custom for Fuji. Someone's asking, did you pay for gas on the failure? So yes, you do pay for gas on failures. Like even if you do something completely wrong on the blockchain, you're still going to pay for gas. Someone's asking if this will be recorded. Yes, like it'll be on YouTube. You can go back to the beginning and start over right now if you want, but as soon as this finishes, it'll be available on YouTube as well on the Chainlink YouTube channel. If you're seeing this right now, it's in the same place. And then can I do the homework later? It's a great question. Yes, it's due by August 25th. Looks like we already answered that in the chat. I'm just repeating what's being said in the chat. You can submit your homework anytime between now and the 25th of August. And I'll be right back, y'all. right, looks like there's a couple questions. Hopefully I'm not too distracting while you're doing this, but someone asked, do the homework answers have to be correct? Yes. Yes, they do. It's a valid question, though. Somebody's asking too what time this goes until. So we've got, let's see, about another hour and 15 minutes, I think. So we'll have this session and then we'll have our talk with Interport. Yeah, there's a question here about source chain. So yes, CCIP does have its own chain ID. It's different than the chain IDs. They would use something like MetaMask. So the homework will be through the type form that you can see right here. So on day one homework, submit your answers via this form. Go there and you'll have the form that you can answer your questions. You need to complete all of the homework by August 25th. So not this Wednesday. You've got a little bit of time. And there's been several people asking about, can we save the typeform progress? I don't think you can. I'm not 100% sure on that, but by default to no. You can answer them like, just save them in a text file. And then you just come through and paste in your answers. Absolutely, Andrew. Thank you for being here. Like, I know people taking time out of their day. It's easy for me. This is my job, but I know people have other jobs. So we appreciate you all being here for sure. Probably going to say this wrong, but Yamraj, if you just want to pop your wallet address into the chat, I'll throw some USD at you on Fuji.
just to share, if people are looking for B&M tokens, Brett just shared in the chat a link that'll take you here. You can mint them directly from our docs. You just need to make sure you pick the right testnet. So we're using Fuji. You can add the token to your wallet, and you can mint the token right here from the docs. Your question about scams on testnets, I personally have never seen any. Doesn't mean they don't exist. I will say I definitely do not follow best practices with my testnet wallet. I keep my wallets separate. So everything I do in testnets, it's pretty free and loose. I haven't run into any problems, but I don't know. I guess they could exist. And then, Trillian, what error are you running into? Feel free to drop it in the chat, and I'll see if I can help you out. Yeah, I guess the only scam I've seen on testnets is people do drain faucets to try to get testnet tokens. I don't know why. Well, I guess I do. It kind of boils down to, at one point in time, was it on Go Early? I think it was on Go Early. There was actual value in testnet tokens, like very slight monetary value. And so people set up bots to start draining faucets. And yeah, since then we've had to be a little bit more stringent on how we allow people to get testnet funds so that our faucet is available. That's why we have like the GitHub and I think it's Cloudflare verification on top of our faucet. So Trillian, are you trying to send from Fuji to OP Sepolia?
Okay, Trillion, let's see. So I'm on Optimism Folia. I'm going to try to go through everything real quick. And let's see here. So this would stay the same on Fuji. Trillion, when you're switching from regular Spolia to OP Spolia, did you change the allow list destination chain as well? That'd be the first thing I'd check. So you need to get a different chain selector. And just as a quick time check for everybody, about 15 minutes, we'll stop our exercise and we'll have the Interport team on. And just check 2 Trillion. You got the correct router and link token address for Optimism Spolia.
and set that to true. I think I can beat it. I didn't beat it. I didn't set it to true soon enough. But trillions, so this worked going between the two. I'd say double check to make sure that you, when you deployed everything, that you gave it the right router, link token address, everything like that. When you're asking about deploying the CCIP receiver contract, are you deploying the full? You should just deploy the same contract on both Fuji and Sepolia. This one contract basically does the sending and receiving. Jim, when you're asking about the revert function, when you call it here, it'll set this value simrevert to true, which means in your process message function, it's going to throw an error. On the CCIP side of things, from the Explorer, you'll see success because CCIP was successful in actually sending the message through. So this should show success, but on your actual contract, when you look at the destination chain, get last received message, this should be empty. If you look at failed messages with an offset, I think it was 0 and a limit of 1, here you would see the message ID
in that status. So then you can continue on. So CCIP successfully sent the message through. That's why you're seeing it here as success. So it's actually able to call into your contract, but your contract on the destination chain, it had an error, and failed as expected. Hopefully that makes sense. It's kind of like this, Jim. Task failed successfully. All right, so our exercise time is just about up. It looks like we have one of the co-founders of Interport here. If you want to give me just a thumbs up in your little window down there, let me, before I pull you on stage, make sure you're good to go. But yeah, we should be transitioning out of our exercise and into our talk with the Interport team here. Vladimir, you good to go? I want to just throw you on stage if you're not. Okay, you're good to go. Cool. All right. Hey,
Cool.
how you doing, Vladimir?
Hey everyone. I'm great, thanks. How are you doing, Richard?
Doing well, doing well. I guess I'll hand it off to you to talk about Interport and what it is and how you used CCIP with it. And I'll be here if you need anything.
Yeah, sure. So as most people know here, probably the CCIP itself is a advanced technology for a cross-chain messaging service where you can use it for any kind of purpose, right? You can bridge assets, you can transfer cross-chain messages with like the information or parameters for the transaction or any other use case basically that you want to implement it for. And so Interport itself is a liquidity aggregation platform that works within all the majority of the EVM compatible chains. And with Interport, we're trying to solve the problem of fragmentation of the liquidity. So one of the key things and barriers, I would say, in the market is the variety of the networks and evolving L1s and L2s, as well as the fragmentation of the liquidity on those chains. Because like more and more capital being deployed and diversified into different liquidity pools, the trading becomes way harder for people. Also, in order to migrate to some other chain to capture the yield or any incentives that are currently available on the chain, it becomes super problematic, even from the perspective of user experience, right? Because you have to buy gas tokens somewhere. You need to find those centralized exchanges to buy the gas tokens. You need to withdraw them to your wallet, register new accounts. You need to find trusted DEXs on that chain. You need to find any aggregation options on the chain to make sure that you're buying at a fair price, right? Not through some small pool with huge price impacts. And this is basically what we built Interport for. So we have the meta aggregation built inside of our product. So that ensures that it always shows you the best rate provided by all the aggregators on every chain for any token. So just to demonstrate it, I'll probably share a screen. Just a second. So yeah, guys, this is the website, and the way it works is that you can basically swap any tokens to any other asset, completely ignoring the fact that it's on different chains, right? So here, for example, I can swap my ETH from Base towards like a cake token, let's say a pancake swap on Binance, right, chain, and that would give me a quote that I would get 17 cakes for my $24 ETH on my Base, right? The way we do it is that we meta aggregate the transaction on the Base chain. So this is the source chain, and Binance in this case is the destination chain. And we also meta aggregate the price on the destination chain, finding the best possible routing for the swap. And what technically happens is that we, as a protocol, taking care of the execution of the actual transaction with the slippage, considering the slippage and setting up to the very possible minimum. The slippage is being optimized as well in favor of user. So we have built a specific ladder-based algorithm that kind of diversifies the slippage and tries to implement the lowest possible one. And by doing so, you can execute a swap with one single transaction. So you don't have to wait for the funds to be bridged and then find the swap on the Binance chain and do the swap, and you do it with the one simple click. So by doing so, we're trying to eliminate the barriers of the cross-chain trading. And Interport is not only the cross-chain swaps aggregator, but you can also use it for gas transfers from one chain to another. You can also use it for bridging assets, so like any tokens, USDC, or anything you want, basically, as long as there is in the list of supported tokens. We pass through all the transactions through our stablecoin pools, and that's how we able to process them safely with a stable slippage and not rug the user, basically, and also produce a very smooth user experience. So you can find the stablecoin pools here. It is very similar to the Stargate ones, but I guess the APYs would be a bit better. You can join a stable pool on any chain. Those are impermanent loss free. So there is no the amount of the asset that you supply will always be equal 1-to-1 to what you supplied when you're trying to withdraw. So this is basically a stablecoin farms that we use as a liquidity for routing the transactions. And of course, when executing the transaction, we're using Chainlink's CCIP as one of our cross-chain messaging providers. And definitely you guys will be contributing to the Chainlink's ecosystem usage by using Interport, though. So let's talk about scenarios and use cases where you need a cross-chain transactions, right? So one of the, if you are about to buy some token, which is available only on one chain, but your capital is mainly on other chain, right? So you can use Interport to smoothly buy the tokens on the different chains using the capital which is located on one chain without the need of bridge, rebalance, and things like this. Use case number 2 is to acquire gas tokens. Use case number 3, the most common use case, is cross-chain arbitrage. So during the market volatility, like yesterday or today, for example, because we wrote through the stablecoin pools. So technically what happens when I'm trying to execute the transaction, let's say I want to sell my ETH on Base to buy BNB on Binance, right? It aggregates, by the way, here you can kind of see the drop down of all the aggregators prices, and we always try to give you the best rate. But if there is any problem with this rate, or you don't want to use OpenOcean, for example, you can always choose any other aggregator and use another routing, right? But technically what happens is that we would sell your ETH here to USDT or USDC. Considering that it's Base and there is no USDT, we would sell it to USDC and get a $24 worth of USDC on Base. Then we would form a cross-chain message transaction that will be passed through the CCIP, for example, to the Binance chain. Our router on Binance chain will receive the cross-chain message with the data that we have $24 worth of USDC available, that we need to buy BNB tokens, that we need to use this specific routing, and the expected amount that we should receive is this. And of course, the final address of the user where we should send those funds. Once the message, cross-chain message received, our router on the Binance will execute this transaction. And because in the middle of that, there is a USDC, right? That allows you for a cross-chain arbitrage. So for example, if there is, let's take Ethereum, for example, right? So technically, you can sell your Ethereum on Base to your Ethereum on Ethereum network, for example. And how that would work, not sure whether it will showcase now, but just as an example. So let's say there is a price difference during the volatility and the chains are not arbed properly, right? And the asset like Ethereum, BTC, or RDNT token, or any other cross-chain token like Stargate, Layer 0 token, or any other token, basically, that you can arbit through Interport in a very simple way. So if you see that on Base, for example, the price is skyrocketing, while on Ethereum it's stable, or on Ethereum it's falling, and on Base it is stable, so the base price for this specific asset is higher than the price for the specific asset on Ethereum, you can simply sell this asset on Base, get the desired amount that will be in USDC, that will be used to buy the same asset by the cheaper price on different chain in one transaction. So if there would be a price difference now, and on Ethereum, the actual Ethereum would cost less, you would end up with receiving 1.01 Ethereum, for example. Let's try and see it, whether I'm not sure whether it will work now, because I cannot manipulate market conditions. But let's try our DNT token. Sorry, it's not on Base, right? So let's go to Ethereum and try RD. Right, and we can go to Arbitrum. Okay. Or where the Radiant is also on Binance chain, yeah. Yeah. Okay. So let's assume we have 1,000 worth of Radiant tokens. Let's try vice versa. Yeah, so for example, right now here, if you have your Radiant tokens on Binance chain, right, you can simply sell them and buy 1,004 tokens on Ethereum chain, because just of the price difference and not sufficient market makers and arbitrage bots. In reality, currently the gas fees would be really high, so the transaction would cost you around $47 because of the high gas. But so it makes absolutely no sense to arbit for tokens. But if you scale the amount, okay, here is the problem with the liquidity, I guess. It's not that big. Yeah, there is a problem with the liquidity not being deep enough. But I mean, you get the idea. Now even you would get 1,006 tokens for the 1,000 that you're transferring. So you can write bots or simply open tabs and monitor cross-chain tokens to perform this kind of arbitrages with different tokens and simply capture the profit. You can use cheap networks like Arbitrum and Binance. There is no need to use the Ethereum, for example, right? So I assume we can try to go actually to the Ethereum just in case. Sorry to Arbitrum, but I don't think it's available now. Yeah, it's yeah. So that's pretty much the case, and how that product would work for you guys. You can set up additional settings here. So you can set up the slippage. You can set up the slippage on the destination chain. You can use the promote if you want, if you wish. That would open up more. Let's try USDT, for example, and Ethereum. So that would open up your chart where you can see the price different, how the price was changing. You can tweak between different settings of how you see the price. In the settings here, you can also switch on and off the aggregators that you want to be used when executing the transactions. So if you prefer not to use Cadbury Swap, for example, for whatever reason, you can just switch it off, or you can keep all of the liquidity aggregators to make sure that you always get the best price. Yep. So that's a little overview for the platform. So again, if you want to perform an interchain swap, do an arbitrage or anything like that, you go to interchain swaps. If you just need to bridge assets one-to-one, like USDT, USDC, or any other tokens that are compatible with CCIP standards or any other cross-chain messaging standards, you can use the bridge section. If you need just to bridge the gas fees, basically you just want some ETH from Arbitrum to Ethereum or vice versa. I don't know, like you can choose any like Linea or any other chain where you want to have your gas fees bridge. You're welcome to use the gas transfer tab. And if you are just looking somewhere to park your stables for safe APRs, that's the place. So you just go to the earn section and to the stablecoin pools. There is also a ATP farm section. This is the revenue share model. So here you can stake ITP and Ethereum LPs and get a real yield distribution APR. So currently it is around 100%, which is paid in USDT, USDC, and ITP tokens. And here is the percentage how it's paid. So it's 56% USDT, 36% USDC, and 6.7% ITP. So this is the revenue share tab. So it is a real yield. There is no emissions paid for the ITP farms, ITP liquidity. So welcome to explore. Upon the execution of the transactions, you may want to navigate to the Explorer, and you can find the Explorer here. So Explorer would show you all the transactions which you can filter: single chain, all transactions, test nets. You can see all transactions pending, confirmed, or reverted. and just filter by them. So currently, like the pending transaction, for example, is like Ethereum from Scroll to Linea. This is probably due to the slippage. All the others will be confirmed. So you can see like some purchases or transfers. So here the guy was doing transfer from FTM, right? Yeah, so the source asset was FTM, USDC, Phantom base, right? So that's pretty much how it works. So here somebody was transferring USDC from Scroll to Arbitrum, 80K, and you can find any transactions and just get the idea of the fact that like everything is working, there is no problems. You can just go to Explorer and see the status of the transactions, that they're being passed and everything's fine. Each transaction is free to view, so you can anyone can open it and check out the data, the source hash, the destination hash, the status of the transaction, times, and things like this. So this is what you can explore. So currently we performed 1.3 million worth of transactions. Total value of those transactions 660 millions, with 280K users. So this is, guys, we've been live for just a little above the year. I would say 1 year and 2 months. The protocol is triple audited. We haven't experienced any risk mitigations or any smart contracts vulnerabilities or anything similar to that. So I mean, I guess we've proven that it is a safe and great platform to use, and we truly hope that it will help you guys to enjoy the DeFi experience, make it more smooth, and help to solve the problems with over-fragmentation of the liquidity. And we want to give a huge shout out to Chainlink and the products that they're building, because CCIP is one of the things that allows us to build such protocols on top. And we are looking forward for all the CCIP updates that are coming up, I guess sooner this year or early next year. We strongly believe that Chainlink is one of the key partners that everyone would like to use from the perspective of security, safety, and sustainability. So just be posted, guys. You're welcome to follow me and ask any questions on Twitter. I'm very open. You can always DM me and ask about like how to use the platform, whether you guys have any problems with it. We have a very helpful community in Discord and Telegram. You're always welcome to drop your questions there as well. And stay tuned for the Interport updates, because we are about to launch more and more products in the field of cross-chain liquidity. And we are looking forward for all the great things we can do for the DeFi. I guess I'm pretty much done with the explanation and showcase of the platform. Do you suggest, sir, we should just give some word to the audience? Perhaps there is any questions or anything like that.
Yeah, I was gonna, if you're open to it, say if anybody has any questions, feel free to drop them in the chat, and we'll take a minute to answer those. I'm curious personally, like, getting started, taking something from an idea through testnets into mainnet, actually creating an application like this. Do you have any advice for people who are just starting that journey? Like, what was your biggest struggle, I guess?
You mean for the builders?
Yeah.
Yeah, I mean, there are plenty of hidden stones on anywhere you go. I mean, can't even say that. So first of all, in terms of advice, I would say that take the time that you're planning and multiply it by 4. and this would be the real timing. So this is just take the funds, the budget that you have or you planned to spend on the product, and multiply it by 2. This is the second advice. I mean, overall, Interport is currently live at 17 chains, I guess, and we're planning to add more and more. We are also actively working now on integrating on non-EVM chains like Solana. I mean, we've been super efficient in terms of capital efficiency, because we never had like huge TVL like Stargate, for example. Like at some point, I believe Stargate had like 2.53 billion dollar worth TVL there. We never had these numbers. Like the maximum we had was like, I think 5 or 6 mil or something. But in the meantime, so with the average TVL of like 5 mil, I would say we performed 600 million volume within a year, which is like 100 times of our TVL basically. That's why the system that we built is very capital efficient. So the capital is used very efficiently. It is rebalanced very efficiently. We help users in a very efficient way, because in our case, like, you can always see the transparent way of the swap that you are making. You see like the routing on the source chain, on the destinations chain. You see exactly how much you're getting. Interport doesn't run any backend jobs, so we're fully decentralized. This is all done on chain. So I mean, to build something within the cross-chain field, the builders will experience all the problems that we have experienced. So with the time, those problems are being solved, because we were kind of one of the first protocols who were building in that case. And like we saw so many things happening, like different chains, like for example Polygon ZK, I think they had a chain-based problem that was squandering and mixing up the bytecode data that was received by the cross-chain message somehow. I have no idea like how the process of decoding was done, or like it's their internal thing, but the fact that the transactions were just failing and like users were receiving wrong amounts, and just because of the chain problem. So we had to kind of switch it off, right? And but it's not only we, like Stargate had this problem as well, and anyone who integrated the chain, right? So you have to acknowledge that not everything depends on you, and there is hundreds of different factors that depend on all the players or integrations that you're making. So like whenever you integrate new chain, you have to make sure that they don't have any technical problems that wouldn't let you to work efficiently. And this is something that happens. You have to plan in advance how you're going to deal with situations when the funds got stuck somewhere, for example, because this is your reputation, right? And like users who are using your product, you are not responsible for their funds, of course, because it's a DeFi, but from the moral perspective and reputational perspective, you do take responsibility, right? So you're trying to help and get back the funds and things like this. So you have to also kind of make sure that you account for it. Cross-chain field is very difficult due to amount of data you have to process. So I mean, if you check, there is like hundreds or even thousands of liquidity pools around all the chains. Every network has some different approach for technical implementations. Like for example, ZK Sync. Like ZK Sync, because of the zero knowledge concept, they have a very different way of the estimation of gas. They have very different way of execution of the transactions, and you have to acknowledge it because your router will be operating there, and such things. You have to just take them to the account. My personal advice, I mean, for the guys who want to build cross-chain things, start with like 1-2 chains, never go to like 10, 15, 20 or something, because like start with 2, 3, make sure you can run them properly. Also, there is a huge problem with cross-chain liquidity because of its fragmentation. This is why Interport was built. So
Gotcha.
anyone who is building some protocols that help to solve fragmentation of the liquidity, of the cross-chain liquidity, is doing a great job, and they should definitely look, continue building in that way, because I believe that sooner or later, I mean, the liquidity should be unified, right?
Yeah.
And there should be instruments that allow you to unify the liquidity among all the chains.
Right.
Yeah.
So
Sorry.
there are just a couple quick questions. And we're coming up on the end of this session for sure. But first question, do y'all have a bug bounty program?
Yeah, of course. Like you can, if you find, not you, I mean, but if the person finds any UI bugs or contract bugs or any potential vulnerabilities, I mean, we do have a bug bounty program that you can report to our Discord, reach out to our mods or community managers or me or anybody else. So UI bugs would be favored with ITP tokens, and they would, the depending on the bug, like how serious is it, right? That would depend from like $50 to like a couple $1,000.
Okay.
For if there is any funds in danger, we do have a bug bounty with up to 5% for that we are offering for a reporting of the smart contract vulnerability. Yeah. So.
Okay, cool. And then there's another question about when you're routing between chains, you all use the stable coins. And the question is that a case of maximizing transaction sizes on each chain, or is it more secure or better supported? Like basically, why are you using stable coins when you go between chains?
Simply due to fact that it is the stable coins, like USDC, for example, is the only asset probably that has the deepest liquidity towards other coins on the destination chain. We can potentially use Ethereum, but like some tokens, they wouldn't have some networks, sorry, they wouldn't have the liquidity for the Ethereum, right?
Gotcha.
So let's say for the FTM chain, for example, or Avalanche, I mean, they do have a wrapped ETH wrapped version of Ethereum, but there is no like native Ethereum there, and the liquidity for wrapped ETH may be low because usually it's not an official Ethereum, if you know what I mean, right?
Right.
And the only stables the only tokens that are kind of they are everywhere and they have liquidity to everything is like USDT and USDC. So it was a kind of a strategic decision to choose a multi-chain routing asset.
So it's just something that's consistent and in between both the chains that you can use as a way to get across them. Perfect. Yeah. Thank you so much. Yeah, I really appreciate this. And like you said, if people have questions, they can reach out to you on Twitter is probably the best place.
Yeah, or just tag me in Discord or in or in our Telegram. I mean, it's where to. So the same nickname everywhere. So
okay, awesome.
Yeah, just
awesome. Well, thank you so much for coming on and sharing about Interport. It's awesome to hear about.
Sure.
Appreciate
Thank you,
it.
Richard. Thank you, Richard. And thank you guys for your time. And I guess I should just drop off.
Yeah.
That's how it works, right?
Cool. Yeah. Thank you so much. All right. So thank you everyone for sticking around through this too. Like you've completed day one. That's awesome. Just a couple of reminders as we close out the day. One, yes, this is recorded. It'll be on YouTube. It'll be there. Like you can go and rewatch it as soon as this stream ends. You can rewatch it again. You can put it on repeat. If you just want to listen to I don't know if they're calming dulcet sounds of my voice, but hey, whatever. So you can watch that there. Day 2, we have Andre coming up. Let me add my screen back on to stage. So day 2, we'll learn more about CCIP's architecture. We're going to build some cross-chain NFTs, and we're going to learn about testing your cross-chain NFT. Just a little bit of a spoiler here. You're going to get introduced to Chainlink Local. I would, if we were in person, ask you to raise your hands. Anybody else find it kind of frustrating when you were testing and doing stuff and you had to wait for your transactions to go through? Chainlink Local fixes that. It'll let you simulate CCIP transactions locally so that they can be done instantly, and you can know if everything's going to work when you go to testnet and then to mainnet, which is really cool. You'll also have some more homework tomorrow as well. Just a reminder, today's homework can be found here. It'll be answered via this form. Homework is due on August 25th. Don't forget, August 25th. That was another question I saw a lot. When's the homework due? August 25th. It reminds me back when I was like a 5th grade math and science teacher. When's the homework due? It's not tomorrow. It's August 25th. So August 25th is when the homework is due. Tomorrow we will be here, same bat time, same bat channel. And yeah, if you have any questions in the meantime, there is that Discord. And then we'll be in the chat again tomorrow answering questions. And with that, I just want to say, you all rock. Congratulations on getting through day 1 of this bootcamp. And I look forward to seeing y'all tomorrow. Well, I guess Andre will see you tomorrow. And yeah, have a good one and keep building.